In this video, I am going to discuss about reactions of benzene. As we know that benzene is a aromatic compound and this is the structure of benzene. Basically, benzene is stabilized by the resonance. Okay, so this is the structure of benzene, and here you can see the carbon and hydrogen bond is there. So because of presence of this resonance and these hydrogens, generally the benzene give the substitution reaction. So when benzene react with any compound, so here because of the presence of these hydrogen in the benzene, they give the substitution reaction. So in substitution reaction, generally attacking reagent, they will substitute the hydrogen which are present on the benzene ring. So here you can see all the 6 position have carbon hydrogen bond. So this is the carbon and hydrogen bond here. So when this hydrogen is substituted by other functional group, then it is called as substitution reaction. And benzene generally it gives the electrophilic substitution reaction. So in reaction of benzene, we will study about the electrophilic substitution reaction. So here the electrophiles, they substitute this hydrogen and they will form a bond. Just I am giving a rough example, and hydrogen will be replaced. So here the electrophile will attack, or it will substitute one of the hydrogen and it will replace the hydrogen. So that is called the substitution reaction. Generally the benzene gave the electrophilic substitution reaction. Now the question arises, what are electrophiles? Electrophiles are the attacking reagents which carry the positive charge, or they are electron deficient. If you want to know more about electrophiles, then you can see my other video on electrophile and nucleophiles. The link will be shared in the description box. There you can see the another video which is of electrophiles. Generally benzene can easily react with electrophile, so they give electrophilic substitution reaction. Here benzene act as a nucleophile and it react with electrophile to give electrophilic substituted product. Generally the electrophilic substitution reaction takes place in 2 steps. So first step is generation of electrophile. That is the first step, generation of electrophile. Second is the substitution of electrophile on benzene ring. So these are the 2 steps through which the electrophilic substitution reaction takes place. First step is generation of electrophile. Second step is substitution of electrophile on benzene ring. So let's discuss first step and second step in detail. Step number 1 is generation of electrophile. So here the compound electrophile and nucleophile, they will split into electrophile and nucleophile. Okay, so this is the generation of electrophile and nucleophile, means simply the spontaneous dissociation of electrophile and nucleophile. Like here we can see one example. Let's see how the spontaneous dissociation occurs. This is the example. Methyl bromide, it's split into CH3 plus and Br minus. So this CH3 plus methyl ion is electrophile because it is electron deficient carrying the positive charge, and this bromide ion, it acts as a nucleophile. So this is the first case or step number 1, that is the generation of electrophile. Next is step 2. Step 2, the substitution reaction. That is the major step in electrophilic substitution reaction, where this electrophile will attack the benzene ring and it will substitute one of the hydrogen. Okay, so here this is the benzene ring. When it react with electrophile, here CH3 plus, that is the electrophile, and then it forms a intermediate complex, and this whole complex carry the positive charge, that is known as pi complex. Okay, so this is the intermediate state where this electrophile, it transfer the positive charge to the whole benzene nucleus and after that the rearrangement takes place, and in rearrangement both electrophile and the place where it will substitute hydrogen, they are present simultaneously at the same site. So here you can see the electrophile and the hydrogen where it forms the bond, both are present at this site, and inside the ring positive charge is there, that is called as sigma complex. Okay, so these two are intermediate type of step, pi complex, and after that pi complex will convert into sigma complex, and at the end the elimination of hydrogen will take place. So after that, from the sigma complex this hydrogen will eliminate and methyl group will be substituted here. So like this. So here the sigma complex will split the hydrogen. So here you can see CH3 and H. This is the sigma complex. Removal of hydrogen takes place and the electrophilic substitution reaction completed. So this is the case where in second step substitution takes place. First the electrophile will attack the benzene ring and formation of pi complex, and the whole compound will get positive charge. After that formation of sigma complex where this electrophile will substitute at one position, and here you can see CH3 means electrophile and hydrogen both are present at the same site, and after that in sigma complex the elimination of hydrogen takes place and this electrophile will completely form a bond with this benzene ring and H plus ion will be liberated. So that is called as electrophilic substitution reaction, means where electrophile have substituted this hydrogen. So that is called electrophilic substitution reaction. So the first reaction of benzene is nitration reaction. Nitration reaction means the introduction of nitro group and O2 group on benzene ring. So this is one of the electrophilic substitution reaction. Introduction of NO2 group takes place on benzene ring. Let's see how this reaction takes place. Generally, the nitration reaction takes place in the presence of nitric acid and concentrated H2SO4, means nitric acid and concentrated sulfuric acid is used as a catalyst here. It required in very small amount. So first we will see the general reaction of nitration, that how it takes place. So this is the benzene. It reacts with nitric acid in the presence of H2SO4. It gives NO2 plus H2O. So this is the general reaction of nitration on benzene. This is benzene, this is nitric acid, this is sulfuric acid, H2SO4. Concentrated sulfuric acid is used as a catalyst. This is nitrobenzene, and elimination of water takes place. So this is the general reaction of nitration. Now I will explain the mechanism of nitration reaction, that how this NO2 group from nitric acid it will substitute on benzene. In nitration reaction, the first step 1 is reaction of nitric acid HNO3 with H2SO4. This is the first step. So when H2SO4 and HNO3, sulfuric acid and nitric acid, they react, then nitronium ion is formed. This nitronium ion is electrophile. It acts as a electrophile. So let's see how this nitronium ion forms. This H plus ion react with nitric acid and it forms a unstable complex, and after that it split into water and nitronium ion NO2 plus. So this is the step number 1, generation of electrophile. So here you can see the formation of NO2 plus, means the generation of electrophile. In step 2, the formation of sigma complex and substitution reaction takes place. So the electrophile which is generated in the first step will react with the benzene ring. So here NO2 nitronium ion which is formed in step 1, it react with benzene structure and it form first pi complex NO2 plus, and then this pi complex will convert into sigma complex. So this is the sigma complex. Now the elimination of proton will takes place. So here NO2 will released or it will be substituted by NO2 group. So this bond between this carbon and hydrogen will break and electrons will move inside the ring, because inside the ring electron deficiency is there. So again this ring will become resonance stabilized and the elimination of proton will takes place. So this is the electrophilic substitution reaction where NO2 plus is a electrophile nitronium ion. It substitute one of the hydrogen on the carbon. So the nitrobenzene will form. So our product is nitrobenzene. So this is the nitration reaction. Next is sulfonation reaction in benzene. Generally this reaction is carried out in the presence of sulfuric acid, that is H2SO4. Again this reaction takes place in two major steps. Number one is generation of electrophile and second is the substitution of electrophile. Okay, so first I will write the general reaction of sulfonation. So when benzene it react with H2SO4, the benzene sulfonic acid will form. So here you can see the general reaction of sulfonation in benzene, where benzene react with H2SO4 and it give benzene sulfonic acid. So again here this SO3H group, it is a electrophile which is also known as nitronium ion. Okay, so it act which is also known as sulfur trioxide. So here SO3H is an electrophile which is substituted on the benzene ring. So this is the general reaction of sulfonation. So now let's discuss its reaction mechanism. First step is generation of electrophile. Step 1, that is generation of electrophile. So how this SO3H group it will generate when two molecules of H2SO4 react with each other. So this is the first step where two H2SO4 molecules they will react with each other and they will form sulfur trioxide. Sulfur trioxide, although this sulfur trioxide is a neutral molecule, but it's one of the oxygen. Although sulfur trioxide is a neutral molecule, but its sulfur atom contains positive charge. So this is the first step, generation of sulfur trioxide. This SO3 is neutral molecule, but its sulfur contains positive charge. So here SO3 will act as electrophile. So this sulfur trioxide will act as electrophile. Now step 2, in that attacking of electrophile. Step 2 is attacking of electrophile on benzene ring. So here the formation of sigma complex takes place. In this the benzene ring will get partial positive charge due to electron deficiency, and this sulfur trioxide it will have negative charge because of its oxygen carrying the negative charges. So in SO3 the sulfur contain positive charge, but the one of the oxygen it carry the negative charge. So here the sigma complex formation will takes place. Now this SO3, so this is the step number 2 where the benzene ring it react with SO3 sulfur trioxide. So in sulfur trioxide the electrons are taken by SO3 and it will acquire negative charge, and the hydrogen, it is already present on the benzene ring. So this is the formation of sigma complex takes place. So the SO3 will get negative charge because the bond which is present here will break and the electrons will be taken by this SO3. So it will acquire the positive charge and it will acquire the negative charge, and here at this position positive charge will appear because of the electron deficiency. And now this structure again react with HSO4 minus, which was produced in the first step where the generation of electrophile takes place. So SO3 and HSO4, they will react and the elimination of proton will takes place. Electrons will enter inside the ring and H2SO4, the regeneration of one sulfuric acid molecule will takes place. Here the elimination of proton occur and electrons, they will enter inside the ring, and the regeneration of second H2SO4. Structure, it react with H3O plus hydronium ion which was formed in first step, and the formation of benzene sulfonic acid takes place and one water molecule will form. So all the three components which are generated in first step are now utilized here. This SO3 sulfur trioxide, it is used in while attacking the benzene ring. Second HSO4 minus, it help in the elimination of proton and the regeneration of sulfuric acid takes place, and the H3O plus hydronium ion at the end, it gives one of the proton to SO3. So the formation of water molecule and benzene sulfonic acid takes place. This is the electrophilic substituted product in case of sulfonation. So this is the benzene sulfonic acid. So this is the overall mechanism of sulfonation in benzene. Next is halogenation reaction in benzene, where the halide groups, they are substituted on the benzene ring. Generally for halogenation reaction, it takes place at low temperature in the absence of sunlight, and this reaction occur in the presence of Lewis acid like aluminum chloride, AlCl3 or FeCl3, anhydrous ferric chloride. Okay, so these are the reagents which can cause halogenation reaction in benzene. Okay, let's take a simple example. First I will write the general reaction of halogenation. So this is our benzene, this is chlorine, any halide molecule you can take in the presence of AlCl3, that is the catalyst ammonium chloride. So this is the halogenation reaction, the general reaction of halogenation, and in that chlorine is used. We can use other halides also like iodine, but for this halogenation reaction the Lewis acid catalyst is mandatory. Without catalyst this reaction can't take place. Now let's discuss the mechanism of this halogenation reaction. Again, the first step is the generation of electrophile. Step 1, that is the generation of electrophile. So when this chlorine molecule, it react with aluminum chloride, that is a Lewis acid, the electrophile will be generated. So this is our electrophile. So here you can see when one of the chlorine positive charge will form which act as a electrophile, and AlCl4 carrying the negative charge. Step 2 is the formation of sigma complex and elimination of proton. So here you can see this is our benzene ring. It react with electrophile and it formed the sigma complex, and this is the carbocation because of the positive charge. Here this carbon is electron deficient. Chlorine will utilize that electron to form a bond. So because of that, deficiency will appear in the benzene ring and the positive charge will appear here on this carbon. Now it reacts with AlCl4 minus and the elimination of proton will take place. So this proton and AlCl4 minus, they will react and it will give again AlCl3 catalyst and HCl. One of the chlorine form a bond with this H plus ion and HCl molecule will be liberated, and again the Lewis acid will be recovered. So here the substitution reaction occur, elimination of proton will take place, and again the regeneration of Lewis acid occur. So this is the halogenation reaction in benzene. So we can write this as HCl plus AlCl3. Friedel Craft alkylation. Generally this reaction used for the preparation of alkyl substituted benzene ring. For this reaction we need benzene, Lewis acid catalyst like AlCl3, BF3 or FeCl3. These are the catalysts we required, and one alkyl halide group. So these are the things which are required for Friedel Craft alkylation reaction. First is benzene, second is Lewis acid catalyst, and third is alkyl halide, where the alkyl group will substitute on this benzene ring. So let's see a journal example of Friedel Craft alkylation reaction. This is benzene. It reacts with RCl, that is alkyl halide, in the presence of catalyst Lewis acid. Let's take an example of AlCl3. So this is the reaction where this alkyl group will be substituted on the benzene ring. Another example, this is benzene ring. It reacts with methyl chloride in the presence of AlCl3. So here the methyl group is substituted and one HCl molecule is liberated. So this is the alkyl benzene group. Okay, these alkyl benzene, they are formed in Friedel Craft alkylation reaction, means the introduction of alkyl group on the benzene ring. For this we need alkyl halide, benzene and Lewis acid. Now let's see the reaction mechanism, how this Friedel Craft alkylation reaction takes place. So step number 1 is generation of electrophile. That is the first step. So here alkyl halide like RCl or CH3Cl react with Lewis acid AlCl3. It generates electrophile. So this is the first step where the generation of electrophile takes place. So this positive charge reagent is electrophile, means electron deficient. So they carry the positive charge. This is the first step, generation of electrophile. Step number 2, that is the attacking of electrophile on benzene ring. Let's take example of CH3+. So here the formation of sigma complex and the cation. So this is the carbocation. Okay, means the electron deficiency at this carbon. The electrons of this double bond are utilized to form a bond between this carbon and CH3 group. Okay, now after that elimination of proton takes place. So elimination of proton takes place and electrons, they will enter inside the ring, and the substitution of alkyl group takes place and elimination of one proton. So this is the step 2, in which the electrophile, it reacts with benzene ring and forms sigma complex and carbocation compound, and after that the elimination of proton takes place, and this is your methyl benzene, the Friedel Craft alkylated product. Now last step, in step 3, this proton react with AlCl4 minus and HCl will be eliminated, and AlCl3, again the Lewis acid is regenerated here. So the catalyst at the end of the reaction, again it is regenerated and the elimination of HCl takes place. So this is the Friedel-Craft alkylation reaction. Basically it occurs in 3 steps. Next reaction is Friedel-Craft acylation reaction. Generally this reaction is used to introduce acyl group in the benzene ring. This method is useful for the preparation of aromatic ketones. For this reaction we need benzene, acid anhydrides or acid chloride and Lewis acid as a catalyst. Again the example of Lewis acid is AlCl3, BF3 and FeCl3. So again it is similar to Friedel-Craft alkylation, but there the introduction of alkyl group. Here in Friedel-Craft acylation the introduction of acyl group takes place on the benzene ring. Let's see the journal example. This is benzene. It reacts with acid chloride CH3COCl in the presence of AlCl3. So this is the reaction, second reaction, when benzene react with acetic anhydride. So these are the example of Friedel-Craft acylation reaction where the introduction of acyl group takes place on benzene ring. Let's see the reaction mechanism, how it occurs. So this is the general reaction of Friedel-Craft acylation. Let's see that how this reaction proceed. Again it is same like Friedel-Craft alkylation where the step first is the generation of electrophile. Step 1, generation of electrophile. So here you can see the acylium ion. This acylium ion act as a electrophile. So here this chloride form a bond and convert Lewis acid into AlCl4 minus, and the electron deficiency will occur on this carbon, and this is the electrophile, generation of acylium ion. So this act as a electrophile. Now this acylium ion, it will attack benzene ring. This is the step first. Now let's see step 2. Step 2 is attacking of electrophile, nation of proton, that is H+. So this is the second step where the formation of sigma complex takes place. This acylium ion, it will attack the benzene and it form a complex. Here you can see sigma complex, and electron deficiency will appear in the ring because the electrons are utilized to form between this C double bond O carbon and this carbon. So again this here you can see the deficiency on this carbon will appear and it will acquire a positive charge and the carbocation formation will take place. Now the elimination of proton will occur. The electrons which are present in the bond will enter inside the ring and the proton ion will be liberated. So this is the Friedel-Craft acylated product here. And this H+, it again react with AlCl4 minus HCl plus AlCl3 occur. That is in step 3 the regeneration of Lewis acid takes place. This is the regeneration of Lewis acid. So here you can see the elimination of HCl and the formation of Friedel-Craft acylated product. So here this is the overall reaction mechanism of Friedel-Craft acylation reaction.